Hello and welcome to a video covering notes for section 4.3 or 4.3a, whichever you'd like to prefer, or whichever you'd like to refer to it as. Here we're going to talk about systems of equations, specifically with word problems. One of the things I really want to mention here is that you'll notice that I have a split screen with Desmos. I'm not going to do any graphing, substitution, or elimination here. I'm going to use Desmos strictly to tell me what the answer to each of these systems of equations is. And the reason we're doing that is because you'll notice that some of the numbers we're going to use are a little bit more messy. There's going to be maybe some decimals. So we're going to use Desmos to do the heavy lifting here. The whole purpose of today is going to be able to write a system of equations that actually describes accurately what's happening. So first of all, you're going to have this kind of general format that you're going to be looking for, where our system of equations is going to be two equations. So you have to write one equation that's going to describe something, and the second equation will describe something else. For the most part, now not always, but for the most part, one of the equations is going to be written in standard form, and then the other equation will be written, well, it could be written in standard form, but it might more closely relate to slope-intercept form is maybe more traditionally what you'll see. But it just sort of depends on what the problem is. You should have two totals because there are two different things happening here. So in a system of equations, if you have two equations, you have to have two equal values, or you have to have two totals. So what you're going to ask yourself here when you read each of these problems is, what are the two totals, and what do those two totals, how do I get there mathematically? What math is being done? So let's look at this word problem where we're talking about a birthday party. Pretty traditional birthday party where you have paintball and a laser tag party. Okay, so those are the two things that are happening at this party. If you're thinking about what are your options? You can play paintball or you can play laser tag. The next thing that you want to know is a little bit more about what the structure of the party will be. Not only are you going to have people attending, you're also going to have to pay for those people to attend. So the first thing you have is paintball. When we're talking about that as an activity, you want to make sure that we're keeping, I like to make a list of all of the information. So I'm going to keep a list here in the margin of everything that's associated with paintball, and then everything that's associated with a laser tag, because those right now, it looks like those are the two things I'm comparing. So paintball, it says, is $19.75 for each person. So to figure out how many people, or to figure out how much the paintball cost, you need to know how many people are playing paintball. That's an important part. I'm going to decide that I'm going to associate paintball with the variable x. I'm always going to use x and y. I'm boring that way. Sorry. The next thing that you want to ask yourself is what's going on with laser tag. So the laser tag is going to be $13.45 per person. It's a little bit cheaper. However, you still don't know how many people are going to choose to play laser tag. So the $13.45 represents per person, and I'm going to use the variable y to describe the number of people that are playing laser tag. So kind of be thinking in your head what maybe a total bill for this activity would look like. The problem with the total, though, is that we need to know how many people and the total cost. So you're looking for two numbers here. The first number is your 27. You know that 27 people attend. Some of them are going to do laser tag and some of them are going to do paintball. You don't get to choose both in this situation. So the first total is going to be 27 people. Maybe 26 of them play laser tag and only one plays paintball, which would be interesting. But somehow we have to find the right combination that's going to give us 27 people that attend this party. The second total is going to be the cost. So you have to pay for people to actually participate in these activities, and that's your second total. If this entire outing costs $451.35, your goal is to figure out how many people of the 27 played paintball and how many people of the 27 played laser tag, because now you know that there were 27 people there, but you're not sure how many of them played each game. So what we have to do is write an equation that's going to help us, or a system of equations, that's going to help us figure out how many people played each game. So we'll have an X and a Y for the number of players. So we've got these two equations here. Think about your totals. The first equation is going to be your first total, which was your number of players. There are 27 people playing, so that's going to be your first total. Your second equation is going to be talking about the cost of the outing. So first you just have the 27 people that choose what to play, and then you have the actual cost of participating in those activities. We're going to write an equation that describes each one of these parts of the system, and then we're going to put that into Desmos and see what Desmos has to say. The next question you're asked is a coefficient. So these are the numbers that are in front of, attached to, multiplied, whatever word you want to use to the variables. This is going to be the individual cost of each activity. I chose for paintball to be the variable X, so each paintball cost $19.75, and then each laser tag cost $13.45, and I chose that to be my Y. Next are my totals. So first, I've talked about this a lot, there are 27 people that play over the course of paintball or laser tag. The second total that we're given is the actual cost to do this activity, so $451.35. If I know that there are only two options here, paintball or laser tag, I know that some people are going to do paintball and some people are going to do laser tag, and I can add those two numbers together, and that should give me 27, because that's how many people are at the gathering. The second equation then would be about the actual bill. So if you know that it costs $19.75 to paintball, now you'll be able to figure out how many people paintballed. So how many times did you pay that? Then laser tag was $13.45, and you know that there are 27 people at your gathering, so you'll be able to use that system to determine, based on your total, how many people chose each activity. So the first equation is about how many people attended the party, and the second equation is about how much it cost to host that party. We're just going to type this directly into Desmos. I'm not going to have you do any algebra. You don't need to rearrange anything. Don't worry about all of that. Just go ahead and type in after you write the system. Just type it directly into Desmos. You're not going to change anything about it. And once you've got both of those typed in, you're just going to kind of want to mess with the graph a little bit. You can zoom in and out. Find that point of intersection, and that is the solution to your system of equations. So you have an ordered pair where you're given two numbers. You have an X and a Y. Your X is 14, and that's talking about the number of people that played paintball. Your Y is 13, and that's talking about the number of people that played laser tag. So you know that the solution to this system is that there were 14 people that played paintball, and there were 13 people that played laser tag. We really, other than writing the system, aren't doing a whole lot of algebra here. You're not really calculating or computing. You're not doing any of that. The idea here is that you write the system using the information you're given, and then you plug the system into Desmos, and it will give you the solution.